provided by UUM students. And Sundarbi has about 1,056 people that stay in Sundarbi, and this number influence to customers, influence waiting and queuing customers at the cafeteria. Okay, at here they serve various of buffets and local dishes. Has and then favorite this is cafeteria is one of favorites cafeteria among the students because their good service and good foods that they provided uh, that makes this cafeteria become a favorite cafeteria for students.
Hi, my name is Nur Azra binti Rashidi. I'm the partner for Farasia for research. So the problem faced at the cafeteria Kata is especially during lunch hour. We decided to run a simulation using Arena software at the cafeteria because we observed that the maximum waiting time for each customer spend at the cafe is within 8 minutes. So this is because Cafeteria Kata is one of the most favorite restaurant among the UM students. Then this is because the cafeteria has good food and good service. So the students come from not only from Inasi Sandabi but other Inasis as well. So we observe the data from 12 to 1 p.m.
What is simulation? Simulation is useful in the study of complex systems. Cornavich 1994 defines system simulation as a practice of building models to represent exciting real-world system or, or hypothetical spatial systems, and of experimenting with this model to explain system behavior, improve system performance, or design a new system with desirable performance. Simulations modeling allows to get better understanding on behavior and system performance. Can be applied to many real systems such as bank or post office. Why we conduct this research? First, to measure the waiting queuing time spent by a customer at the cafe during peak hours. Second, to study the level of performance based on the result of simulations in order to identify the limitations and validations. Third, to develop and compare a scenario of the queuing problem with the real problem by using Arena software.
Okay, these are the simulation at the Cafeteria Kata. First, the customer will enter the cafe and will decide either to choose rice 1 or rice 2. Then there are 4 stations available for the dishes. The customer will choose either to choose station 1 or station 2, and then they will choose either to take the vegetable at station 3 or station 4. And then after taking all the dishes, the customer will decide to either to buy the beverage or no. If the customer wanted to buy the beverage, they will have to go to the beverage counter, and then they will proceed with the payment at the counter. If the customer didn't want to buy the beverage, they will straight away go to the counter station after taking all the dishes. And after making a payment at the counter, they will leave the system. Okay, the first scenario that we decided is to reduce the rice from 2 station to 1 station. So the customer will not have to choose either to take rice 1 or rice 2 because there are only 1 station available. We decided this to reduce the cost and improve the efficiency at the cafeteria kata. Okay, the second scenario at the cafeteria kata is we remove 1 station, which is station 4, the vegetable station. So the customer will only have to choose 1 station to take the vegetable. Okay, so these are the results and findings for our simulation. After we run the simulation at the cafeteria kata, the output performance measure are as shown. We did for 5 replication. For replication 1, the number of customer in is 51. Replication 2 is 54. Replication 3 is 54. Replication 4 is 53. And replication 5 is 45. So the number of customer out is for replication 1 is 34. Replication 2, 32. Replication 3, 40. Replication 4, 35. Replication 5, 32. The maximum waiting time for each replication is for replication 1, 24 minutes. The maximum waiting time for each customer. The second replication is 33.5 minutes. For replication 3, 36.5 minutes. For replication 4, 43 minutes. And for replication 5, 27.9 minutes. So the average waiting time for each customer to in the cafeteria is 7 minutes for replication 1, replication 2 14 minutes, replication 3 16 minutes, replication 4 20 minutes, and replication 5 8 minutes. So the average total time spent for each customer at the cafeteria kata from the beginning until the end for replication 1 is 20 minutes, for replication 2 is 28.6 minutes, for replication 3 29 minutes, for replication 4 33.6 minutes, and for replication 5 21.1 minutes. Okay, so the result for the scenario 1, after we run the scenario 1, so we compare the result between the current model and scenario 1. So the average total time spent for each customer at the current simulation is 20 minutes. But after the scenario 1, the total time spent decreased to 60 minutes. For application 2 is from 28 minutes from the current simulation. After scenario 1, the total time spent decreased to 16 minutes. And for application 3, 29 minutes to reduce to 60 minutes. For application 4, 33 minutes reduced to 15 minutes. And application 5, 21 minutes reduced to 13 minutes. So these are the results for the scenario 2. We compare the average total time spent between the current model and after scenario 2. So for replication 1, the average total time spent from the current is 20 minutes, but it increased to 24 minutes after the scenario 2. For replication 2, 28 minutes for current model and 16 minutes for scenario 2. And for application 3, 29 minutes increased to 33 minutes after scenario 2. And for application 4, 33 minutes reduced to 24 minutes. And for application 5, the total time spent for current model is 21 minutes and increased to 27 minutes after scenario 2.
Okay, for recommendation, we have three. First, can improve its efficiency while reducing cost by removing one of resource which is its rice and one vegetable stations. Although to get better understanding on behavior and system performance, it also modifies system without interpreting the real system. Thirdly, quickly time at long time horizon, or we can slow down the phenomena of the study. Thank you.